Resuming the live stream, unfortunately had a power cut, so everything just turned off because I don't have a UPS. I go YOLO like that on the hardware side of things. Um, let's continue where we were. So we were at the vault. Open up the editor. Let me quickly check if the stream is indeed up. Yep. Let me quickly check if the so we were at the vault. It looks like it's fine. Uh, it will be the second stream with the same title, but I guess that's something that we just live with. Close this one, come back here. Let's start our Nginx and what else? What else do we need? MySQL. So we start Nginx and then we start MySQL, which is essentially MariaDB. These two sites should be up now. They are. Let's pull up our SQL database as well. Oops. What happened here? Okay. This is where we were. Okay. Okay, so we were generating the mnemonic here on the home page. Oh, well, these are here, so why is it not showing them here? This is for the vault. Yes, if current route is slash, I think that's why. No. Hmm. Current route is not defined on the instance but referenced during render. I wonder how it worked the first time. Import seed phrase is not defined. Okay. Let's add. Oh, I was thinking about renaming these to so that we can call them generate mnemonic. Let's go with that generate mnemonic. This would be import mnemonic, which will trigger a open webcam feed, read and pass QR code, and prompt for decryption key. Oh, I spelled decryption wrong. Decryption key. And then do what? Let's leave it at that for now. generate mnemonic. What's the generate import? Generate seed phrase. Let's change that. Mnemonic. What? Did I misspell it or something? Looks like I did, but I don't see. Oh yeah, it's good. Should be gone now. Cool. So these here. Generate mnemonic is the handler. We have the handler added here. On this side, we are issuing the get request to this. This also needs to be changed. Mnemonic, and then it should give us the mnemonic. So on the backend side of it, I added the libraries that we need. These two for now. Over here. And then what we gotta do is generate valid mnemonic. So we'll copy all this function, which is essentially just creating the entropy from new entropy function, and we specify the bit. Oh, this requires a BIP39. So, oh, BIP39 is actually the mnemonic proposal. So we definitely need that. Not the other two right away. We'll see. So let's create a debug variable here as well. So if I go inside of it, it generates entropy of this bit size that we pass on. And in order to create 24 mnemonic words, we need the bit size to be 256. If we use just 128, then we can generate a mnemonic of 12 words, which most of all it still do and is quite secure, but why not have more and more security? The best security that we can afford. So yeah, so I was at the point right before the power cut. I was trying to look this up and make sure this was cryptographically secure. And what that means is essentially is that computers are not capable of generating a true random number. They use our input or some other input in some way, run an algorithm using those inputs, and whatever output they generate, that output they treat it as a random stream of input, random stream. It's essentially if you were able to create the exact same conditions, the values of the same inputs that was there at the time of creating those random character stream or whatever, random number or whatever, then you would get the exact same output because essentially it's working off an algorithm and it's not truly random as such as you roll a dice and you can't really predict whether you'll get a 1 or a 6 or whatever. So that way computers are not able to generate that. So we cryptographically secure means it's not very limited in scope. It's comprehensive enough in the sense that what it generates is quite close to being generating a it's a little hard to describe. It's like as good as quite close to generating a true random number, but a computer can never generate a true random number. So cryptographically secure means that it indeed is using the wide scope of numbers that is possible and choosing one random number out of them and not just being very limited in scope and just picking out of those small scope of the entire space that's possible. Package rand. This is what we Package rand implements a cryptographically secure random number generator. So that is why this package uses cryptorand, because it's cryptographically secure. So we can simply rely on that, and it relies on the operating system abstraction that the operating system provides eventually to provide this data. Let's try to go inside of that. Reader is a global shared instance of a cryptographically strong pseudo-random generator. On Linux, Reader uses getrandom2 if available, dev view random otherwise. On OpenBSD, it uses getEntropy2. On other Unix systems, it reads from dev view random. On Windows system, Reader uses the cryptogen random API. So essentially, on the OS side of things, if this program is running on Linux, it will rely on this function that's exposed by the or the OS, the Linux in this case, or the stream that's coming out of dev view random. And this, the output that it will receive out of this function and out of this stream, is essentially cryptographically secure in a way that the pseudo random number that is generated is strong enough. Coming back to it, so we generate an entropy here, then use that entropy to generate a mnemonic, and then we can showcase that entropy and then mnemonic. So I'll have to change this as well. And mnemonic it has generated. I'll receive that over here and eventually return this. Let's use the abstraction that we created in this, the write JSON, this function. And for that, we simply need to copy over the type that we defined at response. So that's an interface. Okay, so we don't need to do that. That is all it's gonna take. And over here, we can simply say is write JSON and the data that we pass on to it. And over here, we'll be creating different data types to hold the JSON that we'll be encoding, or in this case, marshalling. Right. So over here, we can simply say response and W, that this is the writer that we want to use, which is the response writer of this HTTP request in this case. Let's define that. Let's copy over the generic one that we have here. Generic API response, and we'll create newer ones based on this. Mnemonic API response. So it will be success. There isn't going to be an error as far as I can think about it. And it's not, yeah. Since we're generating in and not fetching from any source, that kind of request cannot fail. So we're good. But we do want to return the mnemonic itself. So we create mnemonic here. And over here we specify inside of JSON, it will have this name. So we create the data type of this here, where response mnemonic API response, and over here we can simply receive this in response.mnemonic, and that should be it. So let's try clicking on that and see what mnemonic is generated in our case. Let's go inside of Vault here and let's compile that into an executable here, and then execute that so that way the firewall does not prompt us again and again every time we run this. So this is the only time it will prompt this, because once we grant this access, this will be for this executable, and that's the name that we will use every single time when we have to run this program. So that way it won't prompt us again. So if I cancel it now and just run it again, see, listening on this port, and the firewall prompt did not get trigger. Okay, let's click on this. Axios is not defined. Okay, very well. Hmm. Hmm. Did it not load or something? Fail to response. What? Open a new tab. It's loading here. But did the URL change? It did. So that's why it's a redirect 302 over here. But where is, oh, there's the request. And it did load. So what are you complaining about? Tell me again. It says Axios is not defined. Okay, let's see. What was happening in this case? Over here, we were simply using Axios like this, and we did not define it anywhere explicitly or even created an instance or anything. Let's search on this. Axios. All four occurrences in this file are the uh, direct uses of issuing a get or a post request, and that's essentially what I'm doing here. But it is still complaining about. Oh, hey Rudra. Yes, you're indeed the first. Actually, since this is like, let me quickly post a message for everyone watching. Since I didn't do that when I restarted this stream. Where were we? We were handling the issue with the Axios. Over here, if we look back, these are the two JS files we load here. And our main.js file, where we data custom code, is loaded at before the end of body tag. And that's it, which is essentially exactly the same thing that we're doing here. I have a typo. Oh, thank you. Oh, thanks for that. Axios. Oh, hey, welcome back. Reloading this now. Clicking on this. So we have to handle the cores. Let's go back to the cores code we were using on the wallet side. Let's copy this and come back here. Was that in the handler or? Yeah, in the handler. Okay. So let's run that again. Oh, we have to compile the server again. Then let's run it again. Still complaining about it. What did I do wrong? Generate mnemonic from vault this. Why is there no options called the pre-flight call being fired here? Hmm, interesting. Is it gonna give me the same behavior in incognito? Yes, so it has nothing to do with the cache network error. Right. Oh wow. Okay, it responded. Okay, so it's not setting the headers here, apparently. Nothing in the response header. So I think, hmm, interesting. I mean, the browser is supposed to halt this request when it doesn't receive the right headers. And before it even makes that request, it would issue this options request, which is why it's called the pre-flight request. And that is how it fetches these headers. So, hmm, I think it's acting up at this point. Hmm. But it does hit the handler here. It hits this. So if it hits this, why is it not setting these headers here? Because if I look into it, the response headers is simply this content and 0 and the date. Hmm. Let's modify this and see whether it shows me this here or not. This would be a string. Since it doesn't show me this, I think an old version of this code is running and not the newer version, which is kind of stupid because I've already tried deleting this file. Oh, it's failed again. What if I simply run this? Let's see what happens now. Same thing. So is it my code that's causing this? I don't see how. Let's, if I type in two double O's here, It only says single O. So that is why it's not okay. I think what may be going on in here. Is this WSL2 in Windows acting up? God. Even the act of compiling my own OS for the Vault frustrated me enough to install a Linux distribution on this desktop. And this again is, these issues will not happen if I was simply using Linux. See, it's supposed to say hello with double O. So it's definitely running the old instance. And if I take a look at the file uh, from here, it does say double O, okay. And if I go to the D drive from here, vault main.go, open that with okay, let's open with this. Hmm, this is interesting. I mean, this editor is running via the WSL layer, so it's essentially a remote uh, container, it is called in the VSC context, and this one is directly opening that file from a Windows install to a Windows file, and this one is a Windows install Visual Studio Code, but accessing it over the WSL layer. Hmm. Hmm. It's pending now. Oh, I'm not even running the server. Running it again. Yep, just a single O here. If I modify it here, it's instantaneously reflected here. So that's not the issue. Maybe the Go, how Go is compiling it is an issue somehow. I don't know. If I change the port here, does it now run on? So it's picking up that change. And if I change the port here, and then try to run it here, click on this, it fails because no CORS headers. And why does it still say hello with a single O? Um, let's add something here. And then what if I issue a request to this? Oops. See, it's still saying hello and not this hello lost def. What is going on? Hmm. Go language compiler not picking up on changes in file. I doubt I didn't describe it well enough, I guess. Google and compiler not picking up. I mean, it's picking up changes because I changed the port and it reflected. And nothing running on this side. But on this side, it did hit this, including this. But it didn't say hello lost dev, which is what it should have said. Golang compiler not picking up changes in log.printf. This is absurd. What if I set these headers? For the time being, I can set these headers on the Nginx side. Sudo nano c nginx sites enabled. And over here, do I need to be in the location block for specifying headers? Nginx add cause headers. Okay, so it's definitely inside a location block. So I simply have to add these 4 headers. Let's add this. We have 3 or 4? Only 3 here. So not this one. Let's copy this as it is. We started in Nginx. So it should work, but why did the Golang did not pick this change up? And this is definitely in the vault and not in the wallet. So I'm not looking at the wrong file. Okay, let's try it again. Will it go through this time? It did not. Okay. Oh, because I'm not running this up. That's why. Running it again. Press reload, clicking this button, and it failed. But it picked up the change this time. What just happened? It picked up hello lost dev for this. So it's not coming inside of this function. What is going on? Uh-oh. Mnemonic, okay. How about now? That was a silly mistake. Okay, now does it say double lots of O? And in the console, it will give us the mnemonic itself, which is this. Cool. So now I'm gonna go back and remove the headers added on the Nginx side, since we figured out what the issue was. Okay, cool. Running the server again. And let's run it again. Generated the seed phrase, we got it here, and different this time, but okay, let's fix this now. Hello, this, and hello. The method here can come for now. I don't mind that. The headers here. Interestingly, we still didn't see the pre-flight options request here. Or did I miss it somehow? I don't think I did. Can't even scroll further. The stupid windows. Anyway, moving on. We removed it from Nginx. Let's try running it one more time. Running. Yes, running. We have it here. Cool. So now we need an um, now we need to show the mnemonic code that we have generated for the user on the UI. So we can use 24 input fields, or we can use just one field and show all of them. But these are not 24, these are like 12 words. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, it's indeed 24. For some reason, I thought, oh, some words were being clipped in the between. That's why I thought they were 12 words. So for now, I think we can show them in just one input field, or maybe a text area. Text area, this will have to attach with the mnemonic variable, which will temporarily hold this mnemonic. And when we receive the response, response.data.mnemonic, response.data.mnemonic is what will go to mnemonic. Let's refresh this. Text area is over here. Let's give it some border so that it's visible at least. I don't know if that will work. Tailwind, border, text area. Okay. Oh, it's view tailwind, something else. This looks nice. I wanna see what the classes attached to it are. We'll simply copy these classes, cause great artist steal. Come back to our page. Jesus Christ, when did I mute? I'm so sorry about that. I really need to build something that can trigger notifications on the basis of me hitting my macro keys, which are on the left of this keyboard. I think I accidentally hit one and then I went on mute. It sucks. And thanks for letting me know. Oh, this happens on every single stream. Okay, back to it. And so now, let's see. Mnemonic generation. Did I cover this here? No, I didn't cover it here. So what I'm trying to say is, let's try to draw it out. Let's use the mind map only. Okay, so once the mnemonic is generated, first of all, you show to user for backup so that they can safely copy it. And then second thing would be to do is encrypt the mnemonic and uh, encrypt mnemonic by a user provided key, which has to be big enough so that it's strong enough. And show the QR code for it, for which it's totally safe to take a picture from your phone or use as a, I mean, no point. I mean, like you can use that as a backup even if you lost this, provided that you remember this. But it's as safe as, just distributing this file to anyone, as long as this key is strong enough to provide the required encryption and safety to this mnemonic. So encrypt mnemonic by a user provided key and show the QR code that the user can scan from their mobile phone. Once they scan it, they have a digital copy, and the next time they use the Vault app, they will boot up, the application will initialize, and then they can simply choose this option of importing the seed phrase, which will open up their webcam. They will show this QR code, and the application will read the encrypted text of mnemonics, prompt the user for the decryption key, and once the user types in, then all of these are known to the program. Only then they are known to the program. The Vault app never stores your mnemonics or any sensitive information. When you power it off, it's gone. It doesn't reside there. If it gets stolen, you have nothing to worry about. So, okay. So encrypt mnemonic, but then there is also this scenario where we want to use a passphrase, provide passphrase to provide passphrase for unlocking wallet. I mean, you can keep this empty and many wallets do that, but I strongly suggest you use this because um, certain situations in real life becomes easy to solve if you're using a passphrase such as a $5 wrench attack, which is, if you are not familiar with, is an interesting way to read about it. Take a quick look. I'll zoom it out. I'll zoom it in. Okay, here this guy says his laptop's encrypted. Let's build $1 million cluster to crack it. No good. It's 4096-bit RSA, so that means it will essentially take forever to crack it. And you always have to. There's a trade-off between how much effort you're putting into something, depending on what the reward potential is. So this guy says, "Blast! Our ill plan is foiled." This is a crypto nerd's imagination, but However, in reality, what actually happens is his laptop's encrypted. Drug him and hit him with this $5 wrench until he tells us the password. So this is the $5 wrench attack. So when such a situation happens, essentially what this passphrase does is no matter what passphrase you provide to any wallet, basically at this point, it will generate a valid wallet. So you can provide a wrong passphrase and it will still open a valid wallet, except there will be no funds in there. So how some people use it, they create their mnemonic code, these 24 words, then they use a passphrase before the wallet is generated using these mnemonic and an empty passphrase. When you provide a passphrase, a new wallet is generated, and there they keep their all of their funds, and they create another wallet with the same mnemonic using an empty passphrase and leave little pennies in there, some sort of balance. So even if somebody was able to gain control of this mnemonic, they will access it and they will come to this realization that there is only little funds in there. So it gives you sort of plausible deniability that uh, your funds are not in there. They are simply can be unlocked by providing the right passphrase. And also, additionally, in cases of when humans die, this becomes the second factor authentication that they can provide to somebody else. I mean, this is also one of the problems that I will try to solve with my perspective on it under the Woodpecker brand, which is this the multi accounts, multi cryptocurrency trustless wallet that I'm building right now is just the project number one. So when it comes to passing on your inheritance, so you can make your family member aware of the mnemonic code in advance, and the actual funds are still locked behind this passphrase. So you can have a mechanism that this passphrase is only revealed uh, when you're dead, or you can even have some automated way of revealing this passphrase to your loved ones when you pass away, so that they already have this mnemonic. They use this passphrase, and the your wealth can be unlocked, and it's not locked away forever, even from your loved ones. So coming back to this, we need a way to encrypt this and show the QR code for it. So the next time the import is like the user doesn't have to type it out or choose the words in a word cloud or in a big ass drop down or something. So that simply covers the convenience aspect with the additional security it's providing, Vault, and then actual passphrase for generating the wallet itself. Right now, we have already generated the mnemonic. We have not generated a wallet. Hmm. Let's see. So when the user loads here in import, QR code will be scanned. This will be populated, and then there will be. I mean, I don't want to show the mnemonic codes except they are when they are generated. So when the user imports them, this text area has no business of being there. So you click on this button, the QR code is scanned, and then it decrypts it, does not show you anything. I mean, obviously, if it fails, then it will show you an error message that it was not able to scan the QR code or was not able to decrypt it. But as soon as you import it, it will ask you for your decryption key. That's the only way to import the wallet in here. Except when you have lost your QR code and you still want to use the same mnemonic with this wallet, in which case you would still want to type it out. So that's an edge case. Hmm. I mean, and it's not practical to have both keyboard and mouse attached to this small device. So that's a good problem to solve. What we can do is upon clicking this import button, we give them two options. First is typing it out. Second is scanning a QR code. Yes, that's what we should do, and that's what we're going to do. Obviously, I'll tweak this UX of the entire UI further later on after this MVP is done. But for now, what we can do is maybe not worry about it. Generate this, use a passphrase here. Input type, text, B model is equal to passphrase. Where does this come from? Okay. B model is equal to passphrase. Save the variable in here. Then let's copy over some styles. Mhm, mhm, mhm. So once we have the passphrase, then we'll need a unlock wallet button or open wallet button. Unlock sounds way better. So unlock wallet is better in terms of importing it, and for generating. Okay, passphrase and then the unlock wallet, which is simply unlock wallet. Which will communicate that the what we have collected from the user is this. So in our context of things, when we generate a valid mnemonic here and we return it here, this gets copied over here. And golang clear variable from memory. I remember seeing a clean function of some sort, which is ideal for usage in such cases. Clear from memory, yeah, this zero. Well, this zero function is defined under here, which essentially calls this zero function, which sets all bytes in the pass slice to zero. This is used explicitly to clear private key, which is this function, which explicitly loops over it and set everything to zero. Okay, dude. This is not an exported function, so that's what we want to do. Golang differ I'll just add a note for now and look into this later. To do clear mnemonic from memory using define. So what happens? This mnemonic generated this passphrase, then these values need to be supplied back to the backend sub. Okay. Perhaps it's better to come up with the UI first, because the different requests that are going to be fired are totally dependent on the user stories involved here, and that is what's causing a little bit of lack of clarity in this case. Hmm. So even if the user is generating a seed phrase, then they will simply choose a passphrase here, click on unlock wallet, and if they're importing it, they will scan the QR code, import the mnemonic, which is in the variable, which is where it is right now. If we have to click on generate, then you choose the passphrase, you click on unlock wallet. Okay, that simplifies it. That gives me the needed clarity that I needed. So we'll define a new function, unlocked wallet, which will be what is it doing? It's reading from the passphrase. Have we tied up the model passphrase to this input field? We have, and to, 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 Okay. Let's see. The passphrase is already tied up to the model, this field. So in the unlock wallet, I would have to issue a post request to the backend API with the handler unlock wallet, which will give me a response of some kind that I will handle here. Take a look inside it by putting it in the console and catch if there is an error and handle that error. How? Here. Perhaps I should be using console.error. Why do we always use console.log for everything? We should use the console.info and console.error methods that are provided. Anyway, doing this, doing that. What unlock wallet? Let's write the unlock wallet handler on the backend side of things now, which is here. So that becomes unlock handler, which will simply be we copy this and we use it here. Oops. Unlock wallet handler. Let's just type it out. So in this case, we will receive the mnemonic and the passphrase. Using that, I'll generate up the wallet and maintain that state on the Golang server. Right. Okay. Hmm. So let's see. We didn't pass on the data yet, so let's do that. How do you pass the data? Like this as a second argument here. Yep, and then just key value pairs. So that will be mnemonic, which will be this dot mnemonic, yeah, and passphrase. I can even simplify it by referring to them just as M and P. This will be passphrase. Saving it. Come on. What's up with this indentation? Let's roll with that for now. So we issue the request here. Then what happens? Then we simply handle it. Over here, we receive the post variables that were posted to us. And let's take a look here. This was a get variable. So add account was a post request. Add account, and we access the post variables using this. We read it from the body, unmarshal that into a known variable, and then we acted upon it. So we copy this from there, simply paste it here. We read it from the body, we convert into a string. So essentially we are logging the string, so we log the JSON, and then we need a data type here, which will be MNP, right? Okay. So type unlock wallet request struct. We will have an M. I want to take a look at this. I think these needs to be capital even if you are unmarshalling stuff into it. Otherwise, they will not be populated. I think. I mean, I don't know. And it doesn't really matter that I need to rely on it, so I'll simply use it. So M. Hmm. Or I can even call it mnemonic here, which is string copied from above, and passphrase, which will again be a string. Changing this here. So will it unmarshal correctly? I don't know. Let's try and see what happens. What's the name of the type you created? Unlock wallet request. So that's this, and did we get s dot mnemonic and s dot passphrase? Let's try that. Let's run the server again, and we have the mnemonics. We use the passphrase QWERTY. We click on this, and nothing happens. Great. Reload it, generate it again, passphrase QWERTY, unlock wallet. So what happened? We we did issue the request, and oh, cars handler. So let's add the cars handler stuff here again. Or perhaps I can use a function at this point and simply call it cars, which will handle all of this. Oh, these are referenced here. Okay, I guess I can do that. R is what? Request, response, request. But that is it. So we replace this with cars and pass it WR. And use the same here, and that should do it. Let's restart the server again. It's up and running. Generate, provide passphrase, unlock. So did receive the mnemonic and the passphrase successfully. But what does it say? Unexpected enter JSON input. Okay, let's see. Let's look at the request itself first. This was the options request, yeah, okay. This was the actual post request. The payload was passed on like this. So I don't see how that can be. This looks perfectly valid. So when we are here, where does this error pop up? Unexpected end of JSON input. Must be here. No, it doesn't. Must be when we were unmarshalling it. This is MNP, and if I look here, I've not defined MNP. What? So if I have nothing here, what happens then? What? So now it complains. I'm a little confused as to what is it I'm doing and what happened here. So it received it as M and P, even though, oh, wait a second. It didn't pass into mnemonic and passphrase. This is simply unexpected end of JSON input is happening in the options request, I think. So in the options request, it is supposed to return. Oh, so it's supposed to return from the handler function itself. In that case, what I can do is boolean, and based on that boolean return, call it pre-flight. So inside here, I turn pre-flight is equal to true, and I simply return at this point. So missing function body. What is it saying? What? Single parameters can exist without any of this. I don't know anymore. It exists. Oh, I think it's when we name it, then we must have it in a parenthesis. Okay. So now, if the pre-flight is true, then what do we do? So we receive pre-flight value here. If pre-flight is true, we simply return. Now that will be the proper implementation, and then obviously, since it's multi-line now, we would want that here. And this should work as expected now, except these names. So let's see. Okay, pre-flight option request, nothing of this output here. And then MNP is simply shown here at this point. And after that, we unmarshal it, no error reported, except that we were not able to populate this. So essentially, what needs to happen is this would be M and P, and then it will work. See, oh, how do I show it that it will? Well, the debug is already true, so it should say form inputs. Is it not? Where debug is bool? I did not turn it on, it seems. Running it again, unlocking it, form inputs, it's received it correctly this time. Okay. So we were able to receive this. Now unlock wallet. So that essentially means we generate the wallet based on this mnemonic and passphrase. For that, we'll refer to the code that I wrote earlier, which is this function, generate BIP44 wallet. The definition lies in here. But inside of this, instead of just creating the seed from it, I create a master at this point, and I simply go ahead and create an address here. Okay, I'm calling additional uh, the next function here, which uses this master private key in here, account 0, index 0. Okay, but for what coin? Okay, so it's this doesn't accept the coin type here, which it should. So we'll modify it accordingly. And we are not, are we trying to unlock wallets at this point? I mean, we are. The unlock wallet, when the user clicks on this unlock wallet button, they expects to see the uh, accounts that are in there for the type of currencies that it supports. Right. So, okay, I'm gonna take a bathroom break and be back. Back. Okay, so where will be? Okay, the action of unlocking wallet. Since the wallet is unlocked now, we want to maintain this mnemonic and passphrase. into the memory. Or we can simply rely on the master private key here. That's something that we can keep. I think that's what I should do. Let's define a generate wallet function here, which receives mnemonic and string and passphrase. Oops, as another string. And this will populate the global variable that we have here, which will be, what's it gonna be? What's it gonna be? I think, I mean, I can keep the mnemonic key encrypted. I mean, like that's a feature. But instead of just saving one bit of sensitive information in the memory as it is, it would be a good idea to encrypt it, and save it. And but we'll explore that further later on because I'll have to do some research on that, learn a bunch of things, and then figure out what is it that I'm trying to do and how that translates into what I need to do in order to achieve that. Okay, coming back to generate wallet, now we have the mnemonic and passphrase, which the handler will hand over to us here. Generate wallet, and it will pass on the s.mnemonic, s.passphrase, and that's it. It will return us the quest. At this point, we obviously want to validate mnemonic first. Passphrase can be anything, and depending on this validation, we return either a success or a false kind of a thing. So J, where response, generic API response here. And how do we validate mnemonic? I mean, essentially, we have to split all of those words and ensure that each word is from the word list that's specified under the BIP39. How do I do that? Let's open up BIP39 here, from which we can open by this. What? Okay. Click on this. Under this, we have 39, 32. Under 39, we have one file here, test file, word list. We have to scan inside of these word list, but is there a helper function that we can use? There should be. Okay, looks like it's already maintaining that here. Set word list English. Okay, so how do we support the language aspect of things in here? Set word list, get word list, get word index. Interesting. I mean, I can always provide a drop down next to the mnemonic key here, which will indicate these words at the time of generation and at the time of import, which will trigger choosing the right word list. Is that all word list that I have? I'm sure we have updates to that as well. BIP39. Mm, It's funny that whenever I search for BIP39 and BIP44, the actual Bitcoin improvement proposals GitHub repository never shows up as the primary result. This is the repository. Over here, we're looking for 39. There we go. So over here it says since describing how it chooses the words from the word list. An ideal word list has the following characteristics: smart selection of words, similar words avoided, sorted word list. Must be encoded in UTF-8 from mnemonic to seed. Okay, bunch of special considerations for other languages which are not English, and 3, 4, 5, 6, 7, 8, 9. So 9 and 8, if I consider these as one, do I have 8 word lists in this package? 1, 2, 3, 4, 5, 6, 7, 8. One is missing. Which one is that? Chinese both while English is here, French is here. Let's use that. English is there, Japanese is here, Korean is here, Spanish is here, Chinese, French is here, Italian is here, Czech. So this isn't there. Right, so looks like I'll have to fork this and add it. Right, GitHub, Tyler Smith, go PIP tonight. Let's check out the issues, possible optimizations, command line usage, add support for Japanese word separators. This was 2 years ago, so it doesn't look like this package is being actively maintained. There are 4 pull requests as well. I don't. This is interesting, but what I have realized is like I'll have to go through the different forks that are in use. Okay, so as I was saying, I realized that the package that I'm using, the Tyler Smith, the Go Bit 39, does not include this word list, so I would want to include that. And um, since it's not actively maintained, and there are a bunch of pull requests and issues that are going on, I'll have to go through everything and then possibly build on top of it. Since pull requests are pending for quite some time now, I don't think it will make sense to issue a pull request to this module. I'll instead fork this module, add all the modifications and everything that I think I'll need, and all pull requests that make sense in this context to include that and be ready with my own package that I will use in here. So, hmm. So I'll do that, and when we what was it that we started to look into this to begin with? We needed a way to verify the words that the mnemonic are indeed valid. Okay, where is this error thrown? Entropy from mnemonic. So split mnemonic words, create a list of all the words in the mnemonic sentence, length, So this only checks for the words, number of words that are in use, and not validate this from the actual, what do you say it? This does not validate the mnemonic. The words in the past mnemonic are indeed from the word list. It does not validate that, at least from what I can see right now. Maybe it does somewhere, and I've not seen it yet. But that's something to find out. Okay, this may be the function that I was talking about. Entropy from what? So here it says, is the mnemonic valid? Attempts to verify that the provided mnemonic is valid. Validity is determined by both the number of words being appropriate and that all the words in the mnemonic are present in the word list. Except it does not check for this. It simply tries to get the entropy from the mnemonic, which simply does the splitting aspect of it, which is this. And over here, mnemonic slice, decode the words into big int. Big int. What is it doing here? New int word length checksum. Okay, so maybe it's doing that here. I'll have to see what data is passing through here and what's going on. So I'll have to check. I'll see that, and then we'll continue with whatever we're up to, which is the unlocking wallet aspect of it, of the vault here. So that will be all for today. And today it's gonna be a short stream anyway. So thanks for watching. Thanks for tuning in. If you like what you see here, you can follow the project. Go to woodpecker.com, WOODPCKR, and you'll see the landing page over there. Click on this link. And if you want to receive updates for the development of this project, you can put in your email in this opt-in, and I'll send you weekly updates. Apart from that, if you like what I'm doing here, you want to catch up with me, give me a follow on Twitter. My Twitter handle is ashfame. It will be on the screen in a moment. So yeah, thanks for watching. Have a good day. Bye.